You are given that f of x is equal to 2x plus 3 for x less than 2, and g of x is equal to x squared minus 4x plus 4 for x greater than 2. Find the composite of gf of x, stating the domain, state the range of gf of x, and find the inverse of gf of x. Okay, so let's just find gf of x. So what that means is first do f and then do g. So we want to do g of 2x plus 3. So that means everywhere there's an x in g, we replace it with 2x plus 3. So we get 2x plus 3 squared minus 2x plus 3 plus 4. Expanding this, we're going to get 4x squared, 6x plus 6x, which is 12x, plus 9. Minus 8x minus 12, don't forget that would be minus 12 plus 4. So we're going to have 4x squared, we're going to have 12x minus 8x, which is 4x, and then 9 minus 12 plus 4, which means plus 1. Now, the range of this must be greater than 2 for it to be substituted into the second function. So for the domain, we need to look for the lower boundary. We'll need to look where 2x plus 3 is greater than 2, which means the range of 2x plus 3 must be greater than 2. Otherwise, we won't be able to substitute in because we're going to substitute values here for x greater than 2. So that means 2x is greater than minus 1. X is greater than minus 1/2. So the domain of this will be minus 1/2 of x is greater than minus 1/2, and the upper bound will be this here, less than 2. Right, now we need to state the range. So all we need to do is take those two values here and stick them in here to get the range. So, gf of 1/2, so substituting 1/2 in here, you're going to get 4 times minus 1/2 squared plus 4 times minus 1/2 plus 1, which gives you 0. And gf of 2 is 4 times 2 squared plus 4 times 2 plus 1, which will give you 25. But you might want to check what the minimum point of this graph is and what value of x it actually lies on. Just so if you do check the minimum point, it will be 8x plus 4, which will give x, when the minimum point will be when 8x plus 4 is equal to 0, and when 8x plus 4 is equal to 0, x is 1/2, so minus 1/2, sorry. So that is actually the minimum point on the graph. So you might want to just check that. Just happens it does actually coincide with the end point here. So the range of our graph gf of x will be between 0 and 25. Right, now to find the inverse, so you let y be equal to 4x plus squared plus 4x plus 1, and you're going to make x the subject, and to do that you really need to complete the square. So you've got 4 times x squared plus 1 plus 1, factorising out of 4, take half of this number here, so it becomes x plus 1/2 or squared plus 1. So added in, we've added in 4 times 1/2 squared. So 1/2 squared is 1/4. So we've added in 1. So we need to take 1. So we get 4 times x plus 1/2 all squared. So this actually was a perfect square. So we can actually see the minimum point is minus 1/2 from that when y is 0. Okay, so now we need to make x the subject. So y over 4 is equal to x plus 1/2 squared. Square root of y over 2 is equal to x plus 1/2. And we only need to take the positive square root in order for our domain. So we've got minus 1/2 plus root y over 2. We'll write that in terms of x, so it'll be 1/2 plus root x over 2, and the domain will be the range of the previous part, which is x being between 1/2 to 25. That will take us back to the domain that we originally wrote down. Okay, this has been a video to show you how to find the composite function and find the domain and the range. I hope you've understood, and I thank you very much for watching.